Okay, chapter 2, environmental systems. I'm not going to go through all of the slides by far whenever you look at the actual PowerPoint that is provided with the book. There's a lot of science kind of review, chemistry stuff, and I'm not going to go through all that. Okay, what I'm going to focus on are some of the other big topics, and then we'll address some of the other scientific topics with the chemistry and stuff on a different presentation. The reason why I wanted to start with this slide, though, is because since this is talking about environmental systems, it's good to know what they actually refer to when they mean system. So systems can mean anything that has a beginning and an end, but also it's interconnected. So there can be very small systems placed within larger systems. The Earth itself may be considered to be a system. Systems may be as small as a single being. So a single bacterium can be considered a system in itself. However, all those systems together, living together in a community, may also be considered a system, which is bigger than one of that population. Then you can move on and up through and move within, up into an ecosystem and up to continents, planets, so up to a global scale. So the term system is a very vague one. So as we move forward through this, make sure that you take that with a grain of salt. I guess that could be a system. There are two real types. We have what we call open and closed systems. Most, especially in science and ecology, biology, are considered to be open. They have inputs and outputs from outside the system. Think of rivers. Rivers can lead into like a lake, so that is receiving input from water moving in, and there may be another river leaving that lake, and that would be an output. That's an easy recognizable open system. A closed system, these are ones that are not nearly as commonly found in nature. Occasionally you'll see them in some ecosystems, specifically maybe an underground cave or something that may be like a landlocked or an island that might be considered a closed system. There's no definite input and output. So like a swimming pool, like an indoor swimming pool, if you think about it in a way, is kind of a closed system. The water only is allowed, it's very confined. There are doors, those kinds of things, right? So closed systems are ones that have definite, they're enclosed and encompassed by some means. Okay, so now let's talk about how energy moves in systems. And we can have very quality energy and not so much. You've probably heard of clean carbs versus not clean carbs. So if you're eating clean, then what you're doing is you're taking in quality energy in the form of those, I'm doing air quotes, clean carbs. Though it can also be much more efficient at fueling your body. But if you just, thrive on a diet of Dr. Pepper and Cheetos, that's not quality energy. It's really not. It's full of byproducts and it's highly processed, and your body actually has to work a lot harder to get the energy out from it and doesn't do nearly as good of a job at the quality of the energy that you're getting from it. So think of it like that, and whenever we're talking about this. So high quality energy, it's very convenient. It is concentrated and it can do lots of work. In another realm, you can think of nuclear fuel as being high quality energy because you get a big bang for your buck there. Low quality energy is very hard and it's difficult to harvest. It's very painstaking. It takes lots of energy to get that energy, and so therefore it may not be nearly as efficient. Energy efficiency is something that we will be calculating quite a bit in this course. So think about how energy efficient is an incandescent light bulb versus an LED bulb. Well, incandescent light bulbs actually produce a lot more heat than they do light. And so therefore their energy efficiency is very, very low. The LEDs, they don't produce much heat at all. And so, but most of their energy is produced as light. So therefore, in terms of light production, they are much more efficient. Okay, I'm sighing here. Feedback loops. Feedback loops are, it happens within a system, and there are two types. We have a positive and we have a negative. Now, I'm going to pause right here because probably you're thinking positive plus sign, it's happy, it's good. No, not necessarily. Okay, don't get caught into that train of thought. And don't also think that negative means bad. That's not really what it means. Positive means addition. Okay, think of it that way. It's where that if you were to add something to it in a certain direction, it continues to move in that direction. That's what we mean by a positive loop. So population growth is one that is very common in this subject, where you have a lot of people born, and then a lot of those people are going to continue to make more babies, and those babies are going to grow up to make more people, and see, therefore we have population growth. That is a positive loop. I'll have more examples of positive loops in the next few slides. Negative loops, remember, doesn't mean necessarily bad. Negative loops occur when something triggers and it leads to a difference in direction. It causes a change. I think the easiest way for me to conceptualize a negative loop is whenever I think of homeostasis. You know homeostasis. Homeostasis is your own body trying to basically stay stable, right? It's maintaining its temperature, its water levels, it's in its happy spot. Well, negative loops kind of help keep that in check. If something starts to get out of whack, a negative feedback loop tends to push it back towards that homeostasis state where we want to be. So see, it doesn't necessarily mean it's bad. Another, a good example of a negative feedback loop is a thermostat. If, let's say, your air conditioner is set to 76 degrees and the house hits 78 degrees, then it's going to send a signal that, hey, you need to turn on. And what it does is it's trying to reset it back to what you have it set at. So see, it's all about resetting, not about being bad. So here's an example of a positive and a negative feedback loop. In this positive feedback loop, let's say you get a job, you make some money, you put it in the bank. That bank, if you don't spend it, it's going to keep growing. And the more money that is in there, the more interest you earn. The more interest you earn, therefore, the more money you get again. And so if you don't spend that money, you may be making $30, $40 every cycle, month, or quarter of the year, where you are getting more and more money, and that's a positive feedback loop. It's adding more upon more upon more. Negative feedback, remember, it's checks and balances. So if you get a fever, right, your body temperature rises, sometimes you start to sweat. And that sweat is a cooling process that your body normally, is a very normal process. And that helps your body temperature drop. All right. So it's resetting it. But if that body temperature rises again, then your body's going to sweat more to help. And then your body temperature, that sweating is going to then lead to a drop in body temperature again. Here's a few more examples. Here's another negative feedback loop. This one is, we will talk about this a lot in ecosystems and stuff. So if you have a lot of prey, say rabbits, mice, something like that, and then you have a lot of those primary producers, well, you have an ample food source. So you're going to have a lot of predators preying on them and eating them. Yes? Okay? And so it becomes this issue, though, that now that you have so many predators and they've eaten all the prey, what happens to the number of prey? Right here. They decrease. So it resets itself. Okay? And in this positive feedback loop, think about this. This is an intrinsic one and within ourselves. This is in our psyche that, you know what? I'm very motivated. I have this goal and I have this goal. Once I meet that goal, that is my idea of success. And now that I have that situation and I feel like I'm successful, I am now more motivated to keep moving on to even greater success. So that is another positive feedback loop. Right? I'm going to let you read through these. You can handle these on your own, and I want you to try to figure out what kinds of feedback each of these situations are. All right? And later on, I'll post the answers.